So basically, this is the overview of the presentation. Give you a summary of the weather technology in the cockpit, also known as WITIC. That's the program that I'm on. And my colleague here, Danny Sims, he's with the Aviation Weather Research Program. I'm sure most of you haven't heard about these programs before, but we do research. And results of, we're going to present some results of the weather knowledge, training, information, and decision-making gap analysis. We're going to review weather impacts and accident scenarios and suggest mitigations, and of course, highlight selected research projects. Now, the weather technology in the cockpit, that's what we do. We don't develop any boxes or any software. We basically do research. And we do the research and we develop recommendations, standard guidance documents that could be used either within FAA or industry. For instance, avionics manufacturers can use our recommendations from research. The good thing about it, we're using taxpayers' dollars to do the research, so the taxpayer gets the benefit of the results on the research. Aviation Weather Research Program, they also perform applied research. So this is the problem. All right, so if you look at this chart here, you see from 2011 to 2020, the various accidents. But then look at the two bottom charts, Part 901, accident factors, and of course the fatal and environmental factors. And you can see weather takes a big chunk out of it. So airplanes today are safer. I'm a human factors guy. So the human is still the weakest person in the system. You can change the system, but you can't change the human. You try to modify their behavior if you could, but that's very difficult to do. So that's the reason why we think that this is very important. Here are some of the contributing factors, like I said, human factors. You know, and this here came out of a lot of research. On the bottom here, this came out of Embry-Riddle. They did a lot of our research when it comes to training for pilots. And it says a pilot who does not understand aviation weather products may be at a high risk of encountering hazardous weather. And that's true. So this is the results from a weather knowledge study that we did, I think it was in 2018, 2019, Embry-Riddle Aeronautical University did it. So when they did the study, they first used students. So the perception was that if you're in a collegiate program, you should score higher. So when we got the results back, we said, well, this doesn't represent the population of GA pilots out there, so let's bring in some GA pilots and give them the same knowledge test. And the results were a bit similar. Notice that the student pilots scored the lowest, private pilot. Well, actually, nobody actually got 70% because you need 70% to pass. And student, private, instrument rated, private and commercial, all didn't get 70%. And then these are the areas that we found the weak areas. So people did well with surface charts and upper level charts, but when it comes to SIGMETs, PIREPs, METAR, satellite data, AirMets, and even weather radar, nobody scored a 70. So I don't know if we're not teaching weather the right way or we need to do a better job teaching it. Then we went and we did some work with AOPA members and the Malibu members too. And the ones that are in red tells you there's a problem if you look at the scores. And most of the guys in the Malibu, not really hidden in them, they're instrument-rated pilots. And the perception is that if you're instrument-rated pilot, you should do better. But there's instrument currency and there's instrument proficiency. And you could be current, but if you haven't flown an instrument approach in I don't know how long, you're not going to be proficient. So this study was done at a tech center a couple of years ago, and what we basically did, we looked at the different presentations for 3 different vendors. Now, most of you are using either some type of weather application, either on an iPad, or you're using it within the cockpit on a Garmin or some type of display in the cockpit. And that information is coming from a vendor. Most of the time, that information comes off of the Aviation weather site, and they add value to it based on the customer's need. So if they found out that pilots like a certain symbol, certain color, then they'll add that added value. The problem with that is that there's no consistency. If you look at those 3 presentations, they're all depicting the same thing, but the color is totally different. So from a pilot perspective, if I'm flying a Garmin today and then I do an Aviation tomorrow, if the presentation is a little different, for instance, the symbology to indicate to me whether my airport is VFR, IFR, marginal VFR, and that symbol is different, it has a different color, there's a learning curve right there. So we want to strive for consistency. The second one, we look at salience. The higher the salience, the better the eyes are able to discern the information. And then we found out that pilots were not noticing when the symbol changed, when the airport changed from VFR to IFR. So we figured, well, why don't we, put it on a tablet and color code it in terms of flight category. Well, that worked, but then the pilot had to take their attention away to look at the tablet and interface with the tablet. And at that point in time, the airplane didn't have autopilot, so the guy was all over the place. So that didn't work. So we figured, well, let's try notifying them. So there's where the wristband came in. So you wear the wristband, it's synchronized with the display, and when the symbol changes on the display, the wristband vibrates. But we need to get the vibration correctly, so at least you can feel it. That worked, but yet pilots were still didn't, because you're in an environment, you're aviating, navigating, communicating, and sometimes you just lose it. So that's some of the research that we did. So now we get to this. What is perception? So I'll explain it to you this way. My perception of an accident is going to be different from yours. We all agree, right? 2 individuals see an accident, and the account of that accident could be different. Kids are better witnesses than adults because we throw in biases, and if you don't like flying, you say, oh, the airplane just fell out of the air. Where the kid would tell you, I saw smoke coming out from the back, and they're better witnesses. But basically it's how we process information, right? We select, organize, and then we interpret it. So you see something with your eyes, or you can use your senses, sensory, and you're trying to figure out what it is, and it has a lot to do with this here. So your perception could be influenced by self-concept, culture, values, notions, experience, and beliefs, and all of us display these type of or when we're doing anything, to perceive anything, we probably factor some of it. For instance, a pilot, when it comes to weather, okay, I flew 2 days ago and the weather was like this, and so today it should be the same. So, or I went there last week or last winter going to Alaska, and the weather was the same, so I think it'll be the same. So that's based on his experience. There's a whole presentation on perception, but I'm not going to go into all of that. All right. But when it comes to the influence on pilot weather, when it comes to perception, these are some of this is the way we process the information. So we have the top-down influence, right? That has to do with your knowledge of the weather phenomenon, influence of flight safety, past experience with weather phenomenon in flight, and then we use the mental model of weather and weather information sources, right? Whether it's accuracy, reliability, or recency. And then, of course, training. And then the bottom-up influence is where we have environmental cues, like we have over here, right? Or out the window, like we have down here, right? So these are all things that are factored into how pilots perceive weather. So this is the gaps from the pilot weather knowledge, basically a summary. And you see here that pilots struggle at depicting weather along the route. So what we found out in some of the research that we did, pilots are planning, when they do pre-flight planning, they're planning from their departure point to their arrival point or destination airport. But in between, they're not catering for what the weather would be like. So they launch, and as they get up in the air and they start flying and the weather starts deteriorating, there's no way out because they should have thought about that on the ground. So as instructors, I would ask you that when you're training your students, I would suggest that every day you fly, ask them to, plan, look at the weather. And whether you're going to do a long cross country or just doing a local flight, because if they practice that every time, it becomes a norm. And so it becomes like second nature. Not wait until they're ready to take their check ride and now they're trying to figure it out. That's too late. And you can't do that in the airplane either. You can't try to figure out the weather while you're in the airplane. You got to start it on the ground. And then you transfer that knowledge to the cockpit. Pilots, as I said, they're not assessing forecast products for accurate mental model, assessing the correct issue, value time for forecast weather, of course, calculating weather conditions, heights correctly, and reading weather information in its entirety. So these are all things that we found from our research. And then when it comes to perception, these are some tips. So pilot perception of weather is influenced by a lack of knowledge of weather. It's obvious if you don't know something, it's very difficult for you to figure it out. That goes without saying. Past experiences, inability to interpret weather displays. When you purchase a display, whether it's a Garmin or Aviation or whatever display you're using, most of the time they teach you with the buttonology, right? You push this button to get to that menu. Most of the time you don't really learn the application. And you probably have to do it on your own or get somebody to help you to do it. Tips for improving perception: understand weather impacts on flight, learn to interpret weather information products, understand its strengths and weaknesses, verify information using all available resources, remember the aim, understand capabilities and limitations of weather displays. And then I put that at the bottom there, that effective decision making and safety rely on the accurate perception. So I'm going to turn this over to my colleague Danny Sims, and he's going to go through some scenarios. And I just want to say that the scenarios that Danny's going to go through, we didn't make this up. We work closely with NTSB, and we pull accidents in from NTSB, and basically with the weather and everything else, to build these scenarios. And this is just to give you an idea. Okay, hey, this stuff does happen. All right, so Danny.
Okay, thank you, Ian. Very good overview and introduction there. And as Ian said, I got some scenarios here that are based off of actual accidents. We work very closely with the NTSB to go back and look at what happened. It's not my intent to pass judgment in any way, shape, or form. I'm going to look at the weather. And because weather was a contributor to each one of these, and see if there were indications. And then, if you remember back to one of Ian's slides where he had scores, and we had highlighted in red several different areas, radar, satellite were some examples. I want to use these scenarios to maybe talk about some of the limitations and the strengths of these products and how they might be able to be used together. So let's just go ahead, and our first scenario was an IFR flight that took off from California and went up the West Coast. Was intended to go to Eugene, Oregon. They encountered convective weather on descent, and they went right through moderate to extreme precipitation, as shown here by the precipitation as shown by on a air traffic controller scope. The mustard colors, and you see the red circle is the accident site. Heavy to extreme precipitation was encountered. The aircraft went down. As I said, it was on descent, so your margin of error is certainly a lot less than when you're en route. And the National Weather Service, they did a post-analysis of this event, and you can see in the foreground here, this picture, there's flattened grass throughout this field, and they estimated that it had to be a downburst or a microburst associated with thunderstorms and convective weather that flattened that grass. And the accident wreckage was just a little bit there in the background, not too far from that. So some of the things that we've seen from accident investigations, and these are things just to pass along to your students too. Not all accidents, but a large portion of them, when they're associated weather, tend to occur in the vicinity of low pressure centers, or they tend to occur in the vicinity of fronts. So if your flight is going to be in either one of those, a low pressure center such as we see here off the west coast that's approaching into Oregon in this example, or in the vicinity of a front, heads up. Doesn't mean you will encounter hazardous weather, but it does increase the likelihood of it. So in this case, we did have a very strong storm that was coming on. This was April of that particular year. The accident site was right on the coast as that storm was coming on. The Storm Prediction Center, this is a NOAA organization that's primarily concerned with severe weather. Severe to them means tornadoes, very strong damaging winds, hail of a certain size. And those are the thunderstorms that they tend to focus on, but they also give these light green areas, which are any type of thunderstorm. And so for aviation purposes, teach your students, it's not just severe thunderstorms, it's any thunderstorm can cause problems. We see for this one that the SPC was giving an outlook. Remember, this is early April, it's early springtime, the West Coast, not necessarily your prime location for thunderstorms. So if they are giving an indication of it, we say that's another heads up, pay attention. Another very, very useful product, and we're getting lots of good feedback as we talk with people. These products have been put out for years. Weather forecast offices around the country, there's well over 100 of them, they put out a forecast discussion twice a day. Now, they can be very, very hard to understand because they're full of technical jargon, but it's getting into the mind of what the meteorologist, what the forecaster at that weather forecast office is thinking. So you start to see some, this might happen, but this might happen, but they have an aviation section too. And in this particular one, I've put in bold some of the things that really stood out to me. An unusually strong early April storm, which we talked about already. Very windy conditions, chance of thunderstorms, strongest winds, good batch of rain coming in the 12Z to 15Z time frame, chance of thunder. You see this occurring over and over and over again. Thunderstorms, very strong winds, and then this thing at the bottom that I, again, put in bold, convection, something we're going to watch today. They're really thinking thunderstorms are going to happen, and they can easily transport higher momentum winds down to the surface. Wow, that was an understatement, okay, in this particular case. So what do we also know about this particular one is the pilot did obtain a weather briefing, but it was at least 6 hours before his flight, when we do not know, and the NTSB does not know, if the pilot received any type of update. Now, it's a convective environment. That's not a static environment. I can guarantee you things are going to change, and that's just true of thunderstorms. They may be short-lived, but it's a very dynamic environment, so get updates. Have your students get an update, even if they got a really great weather briefing. If it was 6 hours in advance and there's thunderstorms being talked about, get an update. Get updates in flight also. Numerous PIREPs were available during this time that were submitted talking about low-level wind shear in this region. Again, look at this information, use it as much as possible. Now, the METAR at Eugene doesn't look that bad necessarily. It's reporting VFR conditions, some gusty winds, and a little bit of light rain, but it's VFR conditions. Well, that's at the airport. That's what the METAR is good. It's a very, very good observation, but it's limited to the airport and somewhat the immediate vicinity. Again, thunderstorm environment could be great where you are, just a few miles, either east, west of you, ahead, behind you. Very different situations. So it's changing, and it can change rapidly. Now, in-flight and ground-based radar is a question that keeps coming up a lot to us. All right? The most current one that you're going to get is from your radar on your aircraft. That's real time. Ground-based radar has a lag to it. It can be on the order of several minutes. processing of the radar itself as it completes multiple scans, as it turns around, gets the information, collects it, sends it to a centralized point for consolidating with other radars and then producing those nice radar mosaics that we see over across the country, can have a latency up to 10 minutes or more with them. So if you really do want real time, trust what you're seeing out your aircraft. Now, that's my lead into weather radar, where pilots tended to score low 1. So I want to spend just a little bit of time. This animation right here is not from the event that I just did, but it's just an excellent example of showing some of the strengths, but also showing some of the limitations of weather radar. The strengths are it's near real time. As I said before, when in flight versus ground base, there's a little bit of latency, but it's on the order of minutes. You get the widespread coverage that you can see. This is over California in the Southwest. You can see trends also, and in this case, you can see these precipitation areas tending to grow and move from the lower right up to the lower left, i.e. in a northwest direction. And so that trend information is very, very good about what particular cells might be doing, but it's not a forecast, all right? It's good for right now and what has happened in the past. And so where is new growth going to occur? Well, I can't necessarily tell you, all right? It may occur in areas where there isn't anything right now. So that's one of the big limitations of radar. It's not a forecast. There's also gaps, blockage, and range limitations. If you pay attention to this area right up in the northeast corner of Arizona there, you can see there's no radar returns up into there, but there's some really nice convex features in the precipitation patterns. Well, that's got nothing to do with the weather, all right? It's the limitation dealing to the range of the radar itself, which we tend to see that out west. It's not 100% coverage. It's pretty good, but not 100%. All right, here's another example that demonstrates the coverage. This is over the Gulf of Mexico, and you can see in the middle, you get this very, very beautiful convex feature. Again, that's got nothing to do with the weather, okay? Because we've got next ride sites that are land-based. Those are our weather radars, and that's how far out they can see. So you're limited in how far you can see, and it's an observation. It's not an indication of future events. Well, so are you just stuck with it, not knowing what's there? No, we can supplement this with satellite information, but this was another area where pilots tended to score very, very low. This is a visible satellite imagery for the same time as the one I just showed you. You can see now just how far the clouds extend out into the Gulf. And with the latest weather radar or weather satellite information that was upgraded basically about 1 to 2 years ago, we get tremendous resolution. I mean, as a meteorologist, I like watching this, all right? You can see the clouds growing, the tops of the clouds just blossoming and blooming, and you know from the radar that this is convective weather. So supplement your radar with the satellite. But again, it's an observation. It's not a forecast of telling you what's going to occur in the future. Also, satellite is great at showing you the tops of clouds, all right? And you can see an indication of that. You can see the convective cells, but it doesn't give you information about the bases, all right? You cannot determine cloud bases from a satellite picture. I don't care who tells you that, all right? You're going to have to use some other type of information, all right? And visible is limited to daytime. So at nighttime, you have to go to IR, infrared, and you lose a lot of the detail that you saw in that visible picture. But this will give you cloud tops. But use the information together with radar information to start to build that complete picture, and as Ian was saying, that mental model of the entire route of flight and the trend information. Are the storms starting really to build and what's going on, or are you starting to see them dissipating? All right, I've harped on neither one radar or satellite or forecast their observations, but fortunately we do have forecasts available to you. This is from the high-resolution rapid refresh model, the HRR. That's a model that's produced by the National Weather Service. They put it out. They update that model hourly, giving forecast out to 18 hours. There's a bunch of products in there that primarily are guidance that are used, that are oriented towards meteorologists, but there's also some very useful products, and we feel that this is one of them. This is reflectivity, a forecast of reflectivity. So you don't need special skills to interpret it, what you're seeing. You don't get confused by a bunch of squiggly lines that you can see on other types of weather maps. But you can look at this and you can follow the precipitation patterns as it moves across. We think this is very beneficial, but however, even a model is not 100% accurate. The one thing I can guarantee you is it's not 100% accurate. There will be uncertainties, there will be limitations in the model itself. It's not going to get the position of those cells exactly right. I'll guarantee that to you. But it will tend to get that region right. It will also tend to show you whether it's a line developing or whether it's just air mass thunderstorms or whether it's some other type of organization that's being done. So use something like this, go, no-go decisions, because it's out to 18 hours, so it's going to be primarily day of or night before you're going to be able to look at this. And enable this to start planning some alternative routing if need be. If you're flying into a place that's forecasted to have a ton of thunderstorms, chances are it's going to happen. Pick some type of alternative routing, change your route determination, and also think about escape route determinations. Don't wait till you're in the sky. All right, scenario 2, we're going to go from convective weather, we're going to go to an in-flight icing one. All right, this was a very, very interesting one. An IFR flight out and back. I'll show you the route that they took, and they ended up ending up in a field in Ottawa, Kansas. This was a flight instructor on board giving instructions to a student. They went out to an airport, did a missed approach, turned around, and came back. When they turned around and started rising, they started encountering freezing rain. This was an aircraft that is certified for flight into icing operations. It has pneumatic boots along the leading edges of the wings. But the pilot said, my boots are shedding ice, but I can't keep up with it, and I cannot maintain altitude. And so he ended up, this is just a picture of some of the ice accumulation on the windshield itself. Now, there was another aircraft, that same time period in that same area, that landed short at Wichita, Kansas, and you can see the ice buildup on these. Fortunately, no fatalities in either one of these. So very, very fortunate, and we were able to get some good feedback from the pilots themselves. I mentioned those WFO summaries. The one that was valid at this time, what I've bolded there is lots of mentions of freezing drizzle, patching freezing drizzle, periods of freezing drizzle this afternoon, freezing drizzle. Well, freezing drizzle at the surface, and I'll show you this, freezing drizzle and freezing rain at the surface is an indication that somewhere aloft you have in-flight icing conditions, all right? And freezing drizzle and freezing rain are large drops, and those large drops are especially hazardous to aviation. Let's see what I else have in there. Oh, station plots, very, very poor scores having to do with station plots. So I've given you this right here. Here's the rough flight route, took off from eastern Kansas, as I said, went out, did a missed approach, shot back. But if you look at the station plots, first of all, I want you to notice that the numbers in the upper left are the temperatures. Everything is at freezing or below here, so it's cold. The numbers in the lower left are your dew point temperatures. And if you look especially in central and southeastern Kansas there, you see that the spread between the temperature and the dew point's not a lot. 2 degrees, 3 degrees, something like that. It's cold, it's humid. All right? So you automatically can pick that up from the METARs just looking at the temperatures and the humidity. Now, there's also some other things to notice. If we look at the station symbols, the present weather symbols, and yeah, there's a lot of them, and I don't even recall all of them, okay? And so it's just like I have to pull out the cheat sheet. But maybe look at some of those that are especially hazardous. Know the symbology for thunderstorms. Know the symbology for freezing drizzle, freezing rain. And I've showed those on the bottom left there. It's the little infinity symbol, and if it's a circle in it, it's freezing rain. If it's a comma in it, it's freezing drizzle. And you've got mist, the 3 lines together. Mist in the form of liquid precipitation that is like a light fog. Oftentimes they're reported synonymously. And then there's drizzle. Liquid drizzle, and you're at below freezing temperatures, all right? That's the definition of an in-flight icing environment. Liquid precipitation at below freezing. The TAFs for this same time period throughout this region, and again, another area where pilots tended to score low, all of them throughout here, we're talking about freezing drizzle, and snow. So the information appeared to be there, all right? So this is all the science that I think I'm going to try to give to you right now. But basically, what's going on when you have freezing rain and freezing drizzle? You have a cold layer aloft, and by cold I mean it's below freezing. You got precipitation that forms there in the form of ice particles or snow. It falls down into a warm layer, and by warm it's above freezing. It melts. You have liquid precipitation, then it falls into another cold layer at or near the surface. And that's where you get the refreezing, either on surfaces, road surfaces, sidewalks, or surfaces such as an aircraft that's flying at low elevation. Remember, this flight did the missed approach, then started to climb back to its altitude to go back. That's when they encountered it. So they went down low, they encountered the freezing drizzle, and then went back up. Bottom line, look at those station reports, look at those TAFs. If you see freezing drizzle, heads up, there's icing out there, all right? I talked about some of the limitations with METARs before under scenario 1. They're for the airport. Lots of good information, but they're for the airport. I would be very, very hesitant to start extending those much further beyond that airport. That's why you might want to look at a regional type of coverage and see what's going on. And if you've got widespread coverage of freezing precipitation, widespread coverage of thunderstorms, then you can get more confidence that you're probably going to encounter in between those stations also. The TAFs are forecast for the airport in the immediate vicinity too. If you're looking for en route information, you're going to have to go to some other sources. But they can give you clues as to what's occurring aloft. So I said, you look at freezing drizzle, you see it at the surface, you know you got icing aloft, but the question comes, where? All right, so go to utilize the forecast icing product, the FIP, and the current icing product, the SIP. The SIP is a diagnostic produced hourly, combining observations with weather prediction models. The FIP is a forecast out to 18 hours. These are available at aviationweather.gov. They were developed under FAA sponsorship, so yeah, I'll do a shameless plug for the FAA there and say, we're doing that, and we're also enhancing them, all right? And we hope to pass off new versions of these probably within the next year and a half to the Weather Service. These, again, are representative products, not from the event itself. But with SIP and FIP, we give you 3 different types of output. First of all, we give you probability of icing, and maybe this is leading to some of the confusion that we saw on some low scores with SIP. First of all, it's as I said, icing probability. This is the probability of any type of icing. It's not necessarily rime, it's not necessarily clear, it's not necessarily trace, it's not necessarily moderate, it's just the probability. And the warmer colors are the higher probability. Well, we also can give you output in the form of severity. We do trace, light, moderate, heavy. Not severe, we do heavy. A lot of discussion went back and forth on this several years ago. We were concerned that if we said severe, it would shut down airspace. And actually, the forecast is a forecast of ice accumulation rate. So heavy made a little bit more sense, but I think we confuse people a little bit because pilot reports are reported severe. But anyway, darker the color, the higher the intensity. I think that's really what you need to know. Unless you're in an aircraft that's not certified for flight into any icing operations, then any icing, regardless of the intensity, you need to be able to exit from that as soon as possible. We have this final one that we overlay with the severity. This is SLD, supercooled large drops. This is what this flight encountered as after they did their missed approach. Those large drops that are especially hazardous. And why are they especially hazardous? Because the small drops will tend to hit upon that leading edge and they will freeze almost instantaneously. You get the buildup along that leading edge, you activate your boots, and then everything works right, it sheds that ice. The large drops hit that leading edge. They do not freeze instantaneously, but they will run back on the wing aft of the leading edge, aft of where your protection is, refreeze back there. You can get a ridge build up along through there, all kinds of things. So you may have your de-icing equipment operating like crazy, and with the supercooled large drops, you still are in a hazardous environment. All right, scenario 3. Again, it was weather related, but this was a very, very interesting case. This was the final leg of a cross-country trip. pilot filed VFR into Santa Fe, New Mexico. He had stopped off in Kansas, I believe in Concordia, and then he was going to do his final leg into Santa Fe. He told the folks there at the FBO, I'm cold, I'm tired, my heater's not working as well as it should be. I think maybe I'll look into getting a hotel for the night. And when he checked on prices, he said, nah, it costs too much. I'm okay, I can press on. So being cold, being tired, being hungry, wanted to try to save some time, wanted to try some money, save some money, he took off. VFR, he encountered IMC, he encountered in-flight icing conditions. He did not immediately try to exit. How do we know all this stuff? Well, the pilot fortunately survived this accident and gave us just a wealth of information on it. So, as I said, he encountered IMC, he encountered in-flight icing, again, an experimental aircraft that was not certified for flight into icing conditions. And he said, I knew better. I knew better. And I violated everything that I knew because I wanted to get back. I was cold and I was tired. All right, this is just some of the scenes from the accident, ice chunks that came off the aircraft. And so anyway. And again, I'm not here to pass judgment on him. This is weather, okay? And so he did encounter weather. But, you know, those were his own words. Again, what did I say? In the vicinity of lows, in the vicinity of fronts is where a lot of weather-related accidents have. Well, sure enough, there's a front. In this case, a stationary front. The forecast discussion coming out of the Santa Fe forecast office at that time talked about there at the bottom where I bolded it, marginal VFR to IFR ceilings are going to bleed into the Santa Fe area. It's going to get worse, all right? As Ian said in one of his slides, in the studies that they did, oftentimes pilots are thinking conditions are going to be better than what they are. Right here you have the forecaster telling you it's going to get worse. So the information was there. In-flight icing, here's SIP and FIP products for this particular event. On the left hand, probabilities, and again, the hotter colors, the higher probabilities. You can see his flight track right through the middle of it. And he kept going. And the severity over here, we've got mostly light icing with some pockets of moderate, but again, for an aircraft that's not certified for flight into in-flight operations, any icing is hazardous, okay? So, as I said, the pilot came back with all types of good information. He didn't check the weather conditions before the flight. He didn't monitor ASOSs. He didn't ask ATC for it. He didn't make any other plans. He had done extensive pre-flight planning up to that point. But again, he said, I just violated everything that I know. I filed VFR, I encountered IMC, and I didn't divert. I just kept going. All right, so what can we take away from that last scenario? We feel that's very, very beneficial to create a process and create a checklist and pass this on to your students. Now, what type of process and what type of checklist, I'm not going to say exactly what. We've got some good literature out there that encourages you to do it. The FAA last year issued an advisory circular 9192 about pre-flight weather briefings and getting that information. There's some good training modules that are out on the FAST website right now about self-briefings for VFR. And I believe by next month, we expect to have one out there on briefings for IFR operations. What they will tell you, this is from the companion documentation to that VFR module, is they will also stress create a checklist and create a process. Here's an example of different weather products to look at, and you just write in there what I looked at, where I got it from, and add some notes in there. Is it forecasting thunderstorms? Is it forecasting, strong winds at the surface, crosswinds, whatever it might be. But the point is to develop a checklist, develop a process, have your students do that over and over and over and over again so it becomes really second nature. Now, I think it was about a year ago, we were asked by a pilots group to give a seminar, and they asked us to give some recommendations starting 6 days out in advance for planning from a weather standpoint. So we developed this, and it's just a recommendation, a suggested process. We broke it out into 3 stages, long-term planning over there on your left, where we said that that's basically 6 days to 4 days out before your flight. We gave some examples, and we'll give that in the next few slides, so you can take a look at that. You can go back and look at it at reference of what type of information you can look at. By its nature, it's forecast information, forecast models put out by the Weather Service to give you an idea of the overall general pattern. You know, we're not talking details, but we're just talking about get a sense of what the weather is going to be, what I might end up encountering. Then the short term, which we defined as 3 days before to the day ahead, we're going to continue to look at forecast products, but there are other now weather prediction models that are available. Higher resolution models providing more information. And as I mentioned before, the HRR with its forecast of radar reflectivity is going to be available at the end of this time period. So look at those models, see if they are continuing the trends that you started to see in the long-term process. And then we get to the immediate term, which we're calling basically the day of. You're getting ready to fly. We really do want you to bring in those observations. You know, don't get me wrong, I'm not trying to say observations aren't any good. They're very, very valuable, but they need to be used in conjunction with your forecast. First of all, use them to verify, are the forecasts really panning out like you expected to see as you were starting to look at days in advance and you've been following it through? And what are the tasks now starting to forecast? But also those en route products are very, very valuable. Again, looking at aviationweather.gov, their graphical forecast for aviation, the GFA tool has a lot of good information. You can slice and dice that by different altitudes and look at what you need and by different phenomenon. So that's what I have. This is one for long-term planning. These are primarily models that are available to you. I do have the WFO forecast discussion down there on the bottom. Short-term planning, these are some things, and you should have access to all of these slides. And then immediate-term planning, where we start pulling in more and more information. Those are our scenarios. I'm going to turn this back over to Ian now for some more discussion and a wrap-up. And I guess we're going to take questions at the end. And as Ian's coming up too, we're over in the FAA Safety Center. We have a... oh, that's yours. Wow. I'll let him talk, okay? I'll sit down.
That's to get your attention. Thanks, Danny. So one of the things we've been researching is trying to find a better way to teach pilots weather. We live in a very, I guess, high-tech world where, you know, people have apps and smartphones and various type of technology. So we're trying to use that to communicate. And what you just saw there, if I can go back to it, so this is augmented reality that we're researching. And basically it shows you how a thunderstorm is developed. So the traditional way of teaching, it's basically you have a book, right? And you read the book and it's printed material. And most of us are sometimes visual learners. Pilots are everything that you do, you know, when you're doing anything with your displays and stuff like this, is all visual, right? So if we're able to do this, and this just shows you what the red arrows mean. If we were able to communicate to pilots in that way, and if you guys visit our booth over there, we have an iPad and we have printed material. You can scan the material and it comes to life. And so you can actually see a thunderstorm and explain what a thunderstorm is. You can scan your sectional chart for a flight that you're planning to take, and it comes to life. And you can actually see the terrain and stuff like that. So it gives you a mental model of what the terrain is going to be like before you actually do the flight. And you can do this at home. We also developed 10 mini courses with a software called Weather Explorer. That's the software that we use to scan the printed material to bring it to life. So, and that's where you can find the lessons. I put this in here because these are tools that are available to pilots. I don't know how many instructors in here actually know about these tools. If you do, good for you. But these are all tools that pilots can use. And you know, if you use them and you're proficient in using them, you should be able to stay out of trouble. you know, there is the I'm safe checklist, right? And then you have the PAVE, which is the personal minimum checklist. And then, of course, you have the risk assessment matrix. And then over here is where you have the risk assessment. So you plug everything in there. And all the stuff I got it out of the Risk Management Handbook, which is an FAA publication. Then, of course, for those of you who watch a lot of TV and you watch insurance, they talk about the 3 Ps. What are the 3 Ps? Price, price, price. Well, the 3 Ps here, you know, in for aviation is perceive, process, and perform. And so basically, if pilots, it's part of the aeronautical decision-making model. And if pilots follow that, first of all, they need to perceive the weather information correctly. And then they have to process that information to make sense out of it before they're able to use that information to inform their decision-making. So if they fail on the first P, then everything else is down the hill. And I'll turn you back over to Danny.
All right, thanks again, Ian. So I just wanted to highlight some of the areas that we are working in under the Aviation Weather Research Program. Advanced weather radar techniques at the top. This is, we're improving what comes out of the ground-based weather radars and how we mosaic them together. A lot of that information is geared towards severe weather forecasting, as I talked about earlier. Severe weather, again, tornadoes, strong winds, damaging winds, and hail. But from an aviation standpoint, we need to know more than that. So we're looking at some techniques to do that, and we've made some advances there. Improved ceiling and visibility. We're actually, I think, shifting away from the ceiling word and starting to use clouds, because if we know where the clouds are, and if we can forecast the clouds accurately, the ceiling then falls out of that. So we're really doing a lot of work there. Also, that's something that we've been doing a lot in order to be able to support the helicopter emergency medical services community. And you know, the HIMSS tool, which a lot of you are familiar with on the aviation weather site, aviationweather.gov. We've often had people say, well, I thought that was just for those helicopter operators. No, it can be used for anyone. In fact, the Aviation Weather Center is upgrading that site. They have a test site that's out now, beta.aviationweather.gov. And they no longer call it the HIMSS tool. They're calling it Graphical Forecast for Aviation Low Altitude. So it's available for any and everybody. And so if you're flying low levels, definitely check that out. And we're putting work into there. Convective weather still continues to be the #1 disrupting weather phenomenon upon the National's airspace system in terms of delays. We're continuing to do some stuff there. High ice water content. I don't know if that's much of a concern to a lot of people here, but basically that's flying high and ingesting high amounts of ice, often found in thunderstorm anvils. And from my knowledge, from what I know, you can get the engine flame out. And it's happened a lot over tropical areas with some Boeing aircraft. Well, I won't say a lot, but Boeing came to us and asked us to help address with that. So we're trying to identify where those conditions are occurring. In-flight icing, my baby, since I'm the project lead for that, and that's why I like to talk about it a lot. Model development enhancements. These are enhancements to the models that the National Weather Service is doing. The Weather Service has a ton of different customers, all right? And aviation is just one of many. So we actually put forth resources to make sure that these models are addressing the concerns of the aviation community. So that's what that one is. We do a really robust quality assessment program. Anything that we develop, we test out, we make sure it's good, we compare it against a baseline of what's there available. We have another icing project that is specifically focused on the terminal area. It's going to be in much greater detail than what we're seeing for the in-flight environment for SIP and FIP. And then turbulence also is one that we've done. We've done some really good work in the past. We first started looking at clear air turbulence at high levels. We extended that down to mid levels. We added mountain waves to that. Our next phase, which we hope to have in about another year, year and a half, is convectively induced turbulence in that capability. So that's work that's been going on. So these are just some of the areas. Again, if you've got questions about any of this, we'll stick around, we can talk. And as Ian and I was saying before, until the thunder boomed and the lightning struck, we're over in the FAA Safety Center. We're set up in the back, so if you come in through the big front door, just make your way immediately to the back. Bypass all the other groups, because, just come to us, and we would love to talk with you some more. And so, what else do we have here, Ian? I'm not advancing. The summary. Why don't we just go ahead and take this? Okay. All right. Thank you, Ian.
Okay, so I think this is our last slide. So basically, summary, adverse weather remains a major cause of general aviation accidents. Major contributing factors in weather-related accidents may be pilot lack of weather knowledge, inability to interpret weather displays, use all weather forecasts and observation products that are available. Multiple weather impacts can occur. Form a complete picture, as I said, a mental model of all the hazards, both for departure, en route, and arrival. That's for the entire flight. Use a process to identify potential weather hazards. And as Danny was saying, talk about the beginning of the planning days ahead. Expect and prepare for deteriorating conditions. Combination of multiple hazards increase pilot's workload. And then the last thing I put there in red, know your capabilities and limitations, because I would also say know your aircraft capabilities and limitations. Because if your aircraft is not equipped to fly in icing, you shouldn't be in icing conditions.